Sorry about that. I kind of ended the last video prematurely on accident, hit the stop button. But anyway, where we left off was we have H2O going from solid to liquid. This is the amount of heat per gram, per grams that it needs in order to do that. We set up our formula. All we had to do is multiply 26 by 334, divide that by 1, and then that gives us our answer. So let's go ahead and do that. So bring in a calculator here. 26 times 334 equals 8,684 joules. Now we can go ahead and divide that by 1 if we want, but it's going to give us the same answer. So it's really not necessary in order to do that. So our answer is 8,684. 8,684 joules. Now, this is our answer, right? This would be accurate. The only thing we really have left to do is look up here and put it in the correct amount of significant figures. Now, it's giving you really one thing in here, 26.0 grams, which is 3 significant figures. It's also giving you a 0 degrees Celsius. I have people ask me sometimes, well, doesn't the 0 degrees Celsius, count as a given? And a temperature in this is a problem when it's at a state of matter isn't generally considered significant. It's only this measurement right here, 26.0 grams is what you look at. So that's 3 significant figures right there, right? So our answer needs to be in 3 significant figures. You can write this in a couple different ways. It's going to depend probably mostly on how your professor wants to see it. You could write it as 8,680 80 joules, or you could write it as 8.68 times, put it in scientific notation here, times 10 to the, what would that be, 3? 1, 2, 3. Either one of those two ways would be correct to the correct amount of significant figures. So this 4 isn't really significant, so you would just round that down to 0. Anyway, I hope that didn't confuse you too bad. Let's do another one here. Alright, so I've added another problem down here. Let me just scroll down. And in this one it says, in a sauna, 122 grams of water is converted to steam at 100 degrees Celsius. How many kilojoules of heat are absorbed when this happens? So with this, we just need to look up on our chart to get our conversion factor to go from water at the liquid state into steam at the gaseous state. So basically, when that happens, let me do a different color here. Let's do that color. Alright, so basically when this happens, water goes from liquid, do H2O, liquid, to gas. It yields 2,260 joules. 2,260 joules per gram. So it does that per gram of water in the liquid state here. So it's giving us, in this problem here, how many grams it is. It just wants to know how much heat is absorbed. So if I told you just convert 122 grams of water to kilojoules with 2260 joules per gram, it wouldn't sound as confusing, perhaps, as this word problem. So that's really all word problems are. You just break them down to the simplest state and then solve from there. But anyway, let's start with what we're given. And you know what? Let's even write out kind of our plan of attack for this whole thing. Okay? I didn't do this on the last one. I'm going to do it on this one. We're going to go from grams of H2O to joules of heat evolved, or let's just keep it simple, but go to joules. We're going to do that using this conversion factor right here. And then we're going to go from joules, because our final answer, remember here, once it in kilojoules, from there we're going to go to kilojoules. So we're going to go from grams of H2O to joules, then to kilojoules. So let's start with our given here. Let me maybe even do this in a different color. We'll do this in this blue here. It's called Robin Eggs Blue. Never even heard of such a color, but here we go. 122 grams of water, H2O. We're going to use dimensional analysis. We know for every 1 gram of H2O, we have 2,260 joules, right? So we're just going to plug that in. Grams need to be on bottom here, so they'll cancel out into joules. So I'm going to write 1 gram of H2O for every 2,260 joules. Then, now you could end here, right? If I stopped right here, take this, times sign off, put an equal sign there, that would give me joules, right? And I would be half right on the problem. You might get some points for doing that, depending on how nice your professor is. But the answer wants kilojoules. So we have to take it one step further, and we have to go from joules to kilojoules. So check off, we've gone from grams of H2O to joules. Now we need to go to kilojoules, and I'll do this even in a different color. So next step of the problem here is to go to kilojoules. So I know that for every 1 kilojoule I have, because kilo means 1,000, right? 1,000 joules. I have 1,000 joules. And that's all that really means. So I know for every 1,000 joules, I have 1 kilojoule. Now this is going to equal some answer in kilojoules. And let's make sure, because kilojoules is what we want. Joules cancel out. Grams of H2O cancel out. I'm left with kilojoules, which is what we want. So probably set the problem up correctly then. So now all we have to do is plug this into our calculator. We have 122 grams times 2,260. Divide that by 1. Multiply that by 1 for this 1 kilojoule. Divide that by 1,000. And that gives us 275.72. So it gives us 275, what was it, 0.72? Yeah, 275.72. Now we'd be correct here as well with that answer, except we have significant figures to think about, right? So we've got 3 significant figures here and 122 grams of water. Remember what I said on the last video, the temperature is not really considered significant. So that means this answer has to be in 3 significant figures. So you would go to 3 significant figures here, 275, then go one further for rounding, that's a 7, so it would really be 276 kilojoules of heat. And that would be our final answer. Whoa, that was horrible. That would be our final answer. Anyway, I'm about at my time limit here, so I hope that helped. Thanks for watching.